Good day, Dr. Chan and everyone. Today, me and my team would like to introduce you all about the use of artificial sweeteners as the solution to solve the sugar tax problem. So, without further ado, let me start off with the introduction. For the introduction part, I, Levinash Naidu Selvaraj, will be presenting it. The problem that was given for our group was the sugar tax for the import and manufacturing of ready-to-drink packaged sweetened beverages in Malaysia starts on July 19, and the business community will be given a 2-month transition period for its implementation. And in order to tackle this problem, we decided to choose between sugar alcohols and artificial sweeteners. In the end of our discussion, we as a group decided to choose artificial sweeteners. Artificial sweetener molecules are similar enough to sugar molecules to fit on the sweetness receptor on a human's tongue. However, they are generally too different from sugar for your body to break them down into calories. This is how they provide a sweet taste without the added calories. The artificial sweeteners that was chosen by our group are aspartame, A-sulfam K, and sucralose. In case if you are wondering how we tested the artificial sweeteners, we did it through sensory evaluation method. We tasted the 3 artificial sweeteners and compared the sweetness of each artificial sweeteners.
The first artificial sweeteners we used was aspartame, which is an odorless white crystalline powder. Its molecular formula is C14H18N2O5 with a molecular weight 294.3. It is derived from phenylalanine and aspartic acid. The sweetness of aspartame is 200 times sweeter than sugar, which means that 1 gram of aspartame can replace 2 teaspoons of sugar. It will hydrolyze under strong alkaline or acidic condition. The picture shows Lipton tea added with aspartame and sugar. According to our result, there is no difference in the color and the viscosity of both tea. However, the tea with aspartame tastes sweeter than sugar, but not as sweet as Asgn K and sucralose. Moving forward, the synthesis of aspartame can be explained by joining the L-phenylalanine methyl ester with L-aspartic acid through dehydration, which is shown in the picture. The functional group that imparts sweetness to aspartame is methyl group. The phenylalanine in aspartame has been modified by adding a methyl group, which gives aspartame its sweet taste. Lastly, aspartame also has its own benefits and disadvantages. Its benefits are having low calorie, which doesn't raise the blood glucose. Only little quantity are needed as it provides a sweeter taste compared to the same amount of sugar and has a long-lasting sweet taste. Its disadvantages are it can't be consumed by PKM patients, and over-consuming will lead to serious side effects like cancer and hepatotoxicity.
Second type of artificial sweetener is A-sulfam K. Canderel sweetener is a pocket-sized sugar replacer that contains aspartame and A-sulfam K with 0 calories. Moving on to the chemical properties of A-sulfam K. A-sulfam K is an ionic compound and is stable under high temperature, so it can be used in cooking and baking. The molecular formula is C4H4KNO4S, and the chemical structure of A-sulfam K is also shown in the slide. The molecular weight of A-sulfam K is 201.24. We added A-sulfam K into Lipton tea and compared the sweetness with Lipton tea added with table sugar. Both of the Lipton tea has the same viscosity. Besides that, Lipton tea added with A-sulfam K had shown more cloudy appearance and lighter color. We could also spot the sediment on the top of the tea added with A-sulfam K. After the sensory evaluation, we came out with the conclusion whereby the A-sulfam K tastes sweeter than the table sugar and aspartame, but is less sweet than sucralose. A-sulfam K is formed by an initial reaction between 4-chlorophenol and sodium, and the reaction ended when acetoacetic acid combined with potassium to form A-sulfam K. The synthesis of A-sulfam K is explained in the figure shown. Only part of A-sulfam K can fit into the sweetness triangle and able to bind to the sweetness receptor site of the tongue. There are 3 sweetness receptor sites which are area X, area B-, and area AH+. Area X interacts through hydrophobic or non-polar properties to the non-polar metal group and ring on the A-sulfame molecule. Area B- has partially negative oxygen. The structure of A-sulfame with a negative nitrogen does not fit the receptor site very well. Area AH+ has hydrogens available for hydrogen bonds to oxygen, which is part of the sulfur group. Moving on to the advantages and disadvantages of A-sulfame K. A-sulfame K does not store in the body, which is the advantage of it. However, it produces methylene chloride, which is a type of carcinogen, and acetoacetamide that may cause DNA strand breaks, which may lead to thyroid cancer.
Hi, I'm Wingy. I will be presenting about sucralose. This is another artificial sweetener that is 600 times sweeter than sugar and provides 0 calorie. Molecular formula of sucralose is C12H19Cl3O8. Sucralose has a molar mass of 397.63 gram per mole. Its boiling point and melting point are 104 degrees Celsius to 107 degrees Celsius and 125 degrees Celsius respectively. It also has a solubility of 283 gram per liter. There's no big physical differences between Lipton tea added with sucralose and Lipton tea added with flavored sugar. Sucralose is the sweetest among all and has a very strong sweet aftertaste. It also has a hint of bitterness. Sucralose is attained by selective chlorination of sucrose 6-acetate followed by deprotection of the acetyl protecting group. The sucrose 6-acetate intermediate is produced by selective acetylation of sucrose. A detailed synthetic scheme follows. Next, the chemical modification of sucrose by the replacement of 3 hydroxyl groups on sucrose by chlorine atoms imparts the sweetness to sucralose. Sucralose is stable under high heat and a broad range of pH conditions. Due to its sweetness, it will cause diabetes, weight gain, leaky gut, and increase the risk of IBS and Crohn's disease. It will also generate toxic and cancerous compounds when heated.
In conclusion, white sugar has the least sweetness taste compared to the aspartames, A-sulfam K and sucralose. Sucralose has the highest sweetness taste compared to the white sugar, aspartame and A-sulfam K. A-sulfam K has the highest viscosity compared to the white sugar, aspartame and sucralose. We would like to thank all of you for watching our video. Thank you so much.